Welcome back. My name is Jaco. As per usual, this is a workshop and I'm a goldsmith and Damia is the person editing and doing all the work. I'm really just a puppet.
But you bring the information.
Bring the information, and we're bringing you information today, and some part of that information is going to involve possibly some noise because there's some cars that's out here, there's some guy working at the back here every now and then with some sort of a power tool. We're not telling you what to do, we're just showing you what we do once a week or once every 2 weeks. Sorry about that at the moment. If you're trying to get into this, you're like wondering what is it like in a workshop, then we are here to tell you what a jewelry workshop goes through. What happens if a signet ring making goes wrong? The customer came in with some metal that she'd like to remodel into signet rings. So I was given some material and I started with making them. Now you know I've made some signet ring videos before. We like making them by hand. What's life about? You gotta have fun, right? And that's exactly how I started this, and I'll explain to you where it all went wrong. Of course we want to use the material, but I don't know where that material comes from. There is a chance that when you mix all these guys together that you might have some contamination, is what I'm saying, in the metal. Go into the whole transaction by telling them and informing them that we're going to try and do this, but if something goes wrong, we'll need to look at the following options.
Yeah.
That's what keeps me safe, and the customer knows exactly where they're standing with it. My ingot gives me a thickness, a straightforward thickness of 4 millimeters. Also moving the ingot to the size that I'm looking for, in this case about 11 millimeters, because I'm looking to end up on about 12 millimeters. Cast it into the ingots, cut off the edges that came off that's rough, and then roll it from the bottom side of the ingot. This is an upright ingot, by the way, so the bottom side tends to be, in mine anyway, tends to be slightly wider. So that's the part that I put into the roller and process that away so that that thickness spreads out to the back. From this point I've got a nice strip to work with. I've rolled it up to the point I need to. I'm tracing my ovals and I'm ready to cut it out. When I got to the point where I started bending the metal, this is when there was a little bit of excess stress on the metal. This is where it's going to tell me the rolling went fine. I knew it had a little bit of hardness to it, but I was still hopeful. But when I bent the metal, I realized it started cracking. And when it started cracking, I started investigating the cracks and I realized it's gotten to a point where it's telling me I'm incapable of doing what you want from me. This is the point where we have to contact the customer. Stop, take a photograph of where you're at, let the customer know. We have to change gears, we have to change direction. So we still want to use the same metal, but we know the metal's not going to react to rolling and manipulating it by hand. So I'm going to try the next step now. I'm going to try and cast these rings. I'm hoping at this point that this material is going to cast well. So I'm expecting something else from it now. I'm in a shop and I happen to have a ring which is exactly the shape that the customer is looking for. There's a method of doing this. I have a few tips. This is a very simple explanation, and I'm going to try and give you as much detail in the simple explanation as I possibly can. Chop up all the sand so it's as fine as you possibly can. Try and avoid that you've got any clumps or anything in there. If you've got something solid in there, that little solid thing's not going to compress at the same consistency as the rest of it. And then when it compresses, it's going to compress around that and you might have issues. There's two parts to this mold. Take this part that has the little protruded part, let's call it the male part, turn it upside down on a flat surface because that's where the mold's going to go in. Start putting and compacting the sand into the mold from the back. Hammer it in, so you're recreating that solid bit. The oil in the sand holds it together. So you're pressing on it, you're compacting it, and it's holding its form. And you build that up right to the top, past the top, and then you take a blade and you cut, or a straight edge, and you just cut that absolutely smooth off. Now I'm looking at the surface that's been compacted, the negative surface, and this is where we're going to take our item, which in our case is going to be a signet ring, and I'm going to press that signet ring very cautiously down into the actual sand. So now I'm recompressing it from the opposite side down. I'm going halfway. This surface right here, if this is the shank, needs to go in first until the shank reaches it, and then halfway down the shank, halfway down the face. As it's been pressed into the sand, obviously there's going to be some sand that I've pushed out slightly, and I just tuck it down in on the sides and on the inside where it's pushed out, just where the ring touches the sand, where it's disturbed it slightly. Once I've done that, if I'm going to bring two parts together of the sand, in its nature it's going to want to stick to each other, and if I put the two molds on top of each other, I wouldn't be able to take those molds apart again. It needs something to release the mold from the other one. I use talcum powder, and I use a little brush and I just brush over the top. I place the second part on top, clicking it in and moving it so that the line, there's a little line on the edge there, lines up. It has to line up because I'm going to take it apart, and for me to get a successful mold, when I have to put it back together, those two parts need to match up. With the ring still stuck and covered with talcum powder, you pour more sand in. So now we're building the second part of the mold. Now the mold has been filled with sand. We're going to open this up. You're not going to just pull it open. You're going to be really gentle with it. You've got to make sure that you can get the best result. If you're moving quick, you're just going to break the thing apart. It's quite sensitive like that. So you've got to be really carefully nudging it up without turning it. Just nudge it up and remove the top from the bottom, split the two parts. You might find that you've got a little bit of distortion, back of a little tweezer, just press it down. If you've got any distortion on the side, that's where the metal is going to run. You go back to the ring itself, and you very gently pry the ring out. The pictures and the instructions you're getting with this tells you you've got to make little breather holes. You've got little breather holes on the side. Some of that metal is going to go down the breather holes, but it will also push out the air so that it will allow the rest of the metal to come down. Those little holes are quite important, and if they go make 4 holes, make 8. To ensure a successful cast. Remember, everything you're doing right now, if it doesn't cast correctly, you're going to have to do it again. So you might as well do it right the first time. And then there needs to be a little cavity from the ring itself. Again, we don't want to disturb the design itself, so I'm really gently pulling a little line. So that's the air hole where the metal is going to flow into and push out on the other side. Those are important. Those are very important. And the second important thing is the hole that you're going to be creating to pour the metal into. That hole needs to be right. Once you've made these little holes, you start carving from the outside, and you work your way in towards the inside. You want to be just above the actual cavity of the ring itself. 2 millimeters would be ideal. The cavity size of that hole needs to be quite big because we're working with gold, and you want to make sure that that metal volume falls into this hole, funnels down into the mold, pushes out to every little cavity that you possibly can, and that there's no obstruction in the way. Ready to cast. We're going to bring those two parts back together. It's a cold cast. You don't have to heat up this mold. The most important thing is you need metal behind the actual ring. So all of this that I've been working with, I've remelted it. Now I'm working with 1 ring cavity to cast 1 ring, but I'm using 2 rings volume to throw in to make sure that there's enough weight to push down into those cavities to fill every little thing, that I've got a perfect cast. I went through to the next one. hoping that there's enough mass behind me. There was, and we created these two beautiful signet rings with these. Everybody was sort of crossing their fingers and hoping that this is going to work out. It was never contaminated. It was just mixed with something that has some sort of a alloy in that allowed for casting rather than handmade. I was so impressed with the way that the casting, which is such a basic concept and such an old way of making jewelry, worked so well in this application. It was a beautiful job. I was very happy to finish it off, and it was a massive relief, and that's how a bad situation turned into a wonderful situation. I hope you guys, as always, have learned something from what our experience has shown us in this workshop, and I'm hoping that there's something that we've mentioned in this video, even if it's the smallest little thing. The community is amazing. We've had overwhelming positive response from you guys. And as for this video, like, subscribe, bell icon. You know what the deal is.
We're both people with many hats. Got about 5 hats on, and we're just pushing forward with this end goal in mind.
We've been received really well in our hometown over here in Henley-on-Thames, and we really appreciate all the support. I've got to get back to work. It is almost the end of the week. Can you see it in my eyes? Stay creative, do your thing. The end. Cheers, bye.